Hi, this is Mrs. LaBarbara. This is Physics Chapter 9, Current, Electricity, Video 4. Today's topic is electrical power. Objectives are know the definition and equations for electrical power, know the different units for power, understand how current, voltage, and resistance affects power, is dependent on which quantity is constant. Understand that energy can change form, but it is always conserved. Be able to determine power in a system with a single resistor. Be able to sketch or interpret graphs of relating voltage, current, resistance, and power with each other. Be able to figure out the constant in a given question and sketch or interpret graphs of relating voltage, current, resistance, and power with each other. So power is putting charge to work. Electrical devices, generally referred to as loads, have power ratings, like hair dryer. For instance, this hair dryer has a power of 1200 watts. Similarly, a microwave, some microwave may have 1100 watts, some may have 1200 watts. Your vacuum has power. All the machines is rated by power. So a 1200 watts hair dryer indicated it transfers 1200 joules of electrical energy to heat, wind, sound in 1 second. So power, we have learned in work energy unit, power is defined how fast you do your work. So it's work over time. And there is another equation is force times velocity. So the unit for power is watt. The watt also, 1 watt is equivalent to 1 joule divided by 1 second. So in electricity, here's the power law. To move electrons requires energy. How much energy is used depends on the strength of pushing. That's a voltage. Higher voltage, you are a lot stronger to push that charge. The other thing that affect how much energy that electron have is how the rate of flow. How many charges are you pushing? Current in the unit of time. Power equals work over time. Remember, work equals Q time potential difference. So we chart and Q equals to, and I equals Q over T. So let's see, power equals W over T. W equals Q times V over T. But Q over T is your I. So power equals V times I, or I times V. The strength of pushing, that's V. The current is I. So power equals I times V. We can use Ohm's law to get more equations, because I equals V over R. So power equals V squared over R. And V equals I times R. So power also equals to I squared times R. Let's take a look at, check your understanding. So which would be thicker or wider, the filament of 60-watt light bulb or the filament of 100-watt light bulb? Explain. So basically, remember, the wider the wire, the lower the resistance. So which one have a lower resistance? So which one has more power? Obviously, 100 watts has more power. So these are the light bulbs. Light bulbs will be connected to your household voltage. So for both light bulbs, this V is the same. So bigger power means smaller R. So which one has a smaller R? 100 watts light bulb have to have smaller R. Smaller R means the thicker filament. So 100 watts have a thicker filament. Next one, calculate the resistance and the current of 7.5 watt night light bulb plugged into US household outlet. So we know V, we know P. How do we find R? So we know V, we know P. How do we find R? Here is the equation. R equals to V squared over P. That gives you 1920 ohms. So you have to have a lot of resistance for a small wattage light bulb. So this way it doesn't, you have a smaller current. the current is P over V, or you can use V over R. Either way, you should get 0.47 amps. That's another equation. Let's take a look at another example. Basically, you just plug in the numbers into equations. The trick is to see what is constant sometimes. Okay, let's take a look at another example. An electric motor uses 15 amperes of current. So you know the current in a 440 volt circuit to raise an elevator weighing 11,000 newtons. What is the speed? So if we know the ampere, we know the current and the voltage, we can figure out the power. Power also equals to force times velocity. So if we know the force, we can find the velocity. P equals V times I, P equals to force times velocity. The two are equivalent. We're trying to find V equals V times I divided by F. So the velocity is 0.6 meters per second. Remember, there are more than one equations for power. You have to figure out which one to use. And to do that, you need to write down what you know first. Different units for power. So it's great. We have all different units, right? We have different equations. These different equations also have derived different units. We know units is watts. So all this is equivalent to watt. I squared times R gives us ampere squared times ohms. V squared over R gives us volts squared divided by ohms. V times I gives us volts times amperes. So again, all these are equivalent. They are equivalent to watt. Check your understanding. So 60-watt bulb in a household lamp. A household lamp means V is constant for all kind of light bulbs. Was replaced with 120-watt light bulb. Then how many times greater would the current be in that lamp circuit? So this is V. In this relationship, you're trying to find a current. Remember, there are two equations has current and the power. So power equals to I squared times R. Power also equals to I times V. Which one do you use? If you want to try to find a current, the other quantity has to be constant. If you're trying to find relationship between power and current, the other quantity has to be constant. The V is constant here, so you have to use P equals V times I. So because V is constant, bigger power means more current. Okay, so the 120 watt would have double the current. Which is a unit for electrical power? So take a look at the equation. Electric power is volt times ampere, so it's not the first one. Electric power equals I squared times R, so ampere squared times ohms. That's not it. It's ampere squared times ohms. That's not it. Equals to V squared over R, so it's volt squared over ohms. D is the answer. Graphs of power versus R, I, and V. So it's again, what the graph looks like depends on what is constant. When V is constant, P is directly proportional to I. When V is constant, P is inversely proportional to R. So we can't really graph I squared and R when V is constant because both are changing here. So here is V is the slope in this case. In this case, it's inverse related to R. Now, when R is constant, P equals I squared times R. That means P is directly proportional to I squared. It's a parabola. Okay? And when R is constant, P is directly proportional to V squared. So it looks like direct squared. Looks like that. So this, what the graph looks like, as you can see, there are two graphs. P versus I can be direct or can be direct squared. So the shape is determined by what is constant. Check your understanding. So as the resistance of a constant voltage circuit is increased, so this is V is constant. As R is increased, Remember, P equals V squared over R. As R is increased, the power has to decrease because P equals V squared over R. Why do we choose this instead of I squared times R? This is because it tells us the voltage is constant. So in this, if you want to find a relationship between P and R, the other quantity has to be constant. So the quantity that's constant is voltage. That's why we choose this equation. This is P and R are inversely related. So if R increase, P has to decrease. Next question, to increase the brightness of the desk lamp, the student replaced 60 watts light bulb with a 100 watt light bulb. Compared to the 60 watt light bulb, 100 watt light bulb, does it have less resistance, draws more current, less resistance, draws less current, has more resistance, draws more current, or more resistance, draws less current? So basically, how is the power related to the resistance? That's the first part. So this is the desk lamp. Desk lamp means V is constant. It doesn't matter what light bulb you plug in, your voltage source is the same. So we have to use this equation. P equals V over R. Bigger P means less R, so has to have less resistance. Can only be A or B. Next one, how about current? Well, current equals V over R. So if R is less, V is the same. R is less means I has to be more. So current has to be more. The answer is A. Another example, match the set of variables for question A to D, actually in this case A to C, to one of the 5 graphs. Relationship between power and current for fixed resistance. So power and current for fixed resistance, that will be this one, P equals I squared times R. This is a parabola. So the answer is B. Relationship between power and current for a fixed voltage. That will be P equals I times V because voltage is constant. So that's a direct relationship. That's A. Relationship between power and resistance for fixed voltage. That will be this one, P equals V squared over R. This is the inverse relationship. So the answer is C. That's it. Thanks for watching.